Football is one of the biggest sports in the world, and with this comes numerous controversial goal decisions that have been made over the years. For example, in the 2010 World Cup, one of the more major controversies occurred when England were wrongfully denied a goal against Germany, which would have put them through to the next round. This was because no goal line technology was used, which could have prevented this scenario and countless others. Currently, they have a goal line monitor in place, but it isn't used, and often the decisions made are still incorrect. Our main objective is to devise a system that can utilize the motion sensor to detect when the ball crosses the goal line in order to accurately award goals. Another objective we have is to use the pressure sensor to aid teams in training to help them better analyze their player movements to provide them with useful tactical data.
To build a system capable of accomplishing these objectives, we decided to make use of 6 sensors in total. 2 of them would be the passive infrared motion sensor, produced by American manufacturer Zilog. They function by placing 2 sensing elements inside the body behind a lens, waiting to receive infrared radiation from the outside. Once properly calibrated, any large enough change in received infrared rays would result in a change in its output voltage. As for the remaining 4 sensors, we're using the pressure sensor model from NXP USA. It works by utilizing a monolithic silicon sensor to detect pressure and a single element transducer to convert that value into an analog signal for a DAC to process. This particular model can handle up to 700 kilopascals of pressure.
All the system sensors will be inputted and read to our LabVIEW block diagram. The motion sensors will remain as a voltage reading, and the pressure sensors, we will convert them back to kPa so we can see the difference, or we can tell exactly how much force is being applied when there's no pressure on them and pressure on them. For the data acquisition / readout, both of the pressure sensor and the motion sensors will be outputted to an Arduino board, where it will light up when it goes over the set value we put it on. For the sensor calibration, so we can find that set point, we will set both of the pressure sensor and the motion sensors to 0 when there is no input going through the channel.
Overall, the solution proposed by our team can avoid numerous situations in which goals have been permitted or disallowed based on the decision of the referee. This was done by dividing the area into 4 quadrants with a pressure sensor placed in the center of each. Our system is able to monitor a soccer ball as it crosses the goal line, identify its motion, and determine whether the entire ball has passed the boundary. Our sensor can be used in an industry as safety mechanisms so that if objects cross over a certain threshold or breaks any safety lines, the monitor sensor will detect this and turn off the power to the machine in order to prevent any unwanted injury. The pressure sensor can also be used in safety mechanisms to detect when someone steps in a location near dangerous machinery where they shouldn't and are at risk of getting caught or hit by the machine. This system may be utilized in sports or in any other area where there is a distinct barrier that can or cannot be crossed, making this application incredibly flexible.